5.5 practice, the answers. So the first one here, we're looking at this. We want to know which of these three, A, B, or C, is the mean and which one's the median. Remember, if it's skewed this direction, the mean is going to be pulled that way, so C is the mean. And this is the mode, one that goes most often, but the median, the one that's halfway through, 50%, is also drawn this way a little bit, so that would be choice B. With number 2, okay, we have this graph right here. And which one is the mean or the median? Now, notice this is very symmetrical, so it's not drawn one way or the other. So the mean and the median are both choice A. Okay, so being symmetrical, we know mean and median are both right in the middle. Okay, number 3, we're looking at the ounces of bags here, chips. So the distribution of weights of 9-ounce bags of chips, a particular potato chip is approximately has a mean of 9.12. So generally your 9-ounce bag of chips actually has a little bit more than 9 ounces in it. Okay, so our mean is 9.12 and has a standard deviation of 0.05. Okay, so we just want to label stuff in here. So you take your, I'll just show you the calculations you have to do here. So you take your 9.12 and to find one standard deviation above, you have to add in one standard deviation. So 9.17, add another standard deviation for 2, be 9.22, and 3 standard deviations above, add another 0.05, and be 9.27. Okay, now if I want to go standard deviations below, one standard deviation below, I have to take that 9.12 and subtract 0.05, so 9.07. 2 standard deviations below, subtract another 0.05, you get 9.02, and subtract another 3 standard deviations, you got 8.97. Okay, so there you have your number of standard deviations, which is also the z-score, and the actual amount. Okay, number 4, we're asked to find these probabilities. Okay, so we got to remember this here. In a distribution, I'll kind of write it out here. So in any distribution, within one standard deviation is 68%. Okay, so that means it's 34% here and 34% there, half and half. Within 2 standard deviations is 95%. So if I take 95 minus the 68 out, okay, that gives me 27, and divide it by these two, I get 13.5. So I get 13.5 here and 13.5 here. Okay, and within 3 standard deviations, I have 99.7%. So if I take 99.7%, subtract away the 2 standard deviations, subtract away the 95, I'm then left with just these 2 areas. And I divide that by 2 for both of them. I get 2.35. Okay, so that's 1, 2, and 3 standard deviations away. Okay, so if we look at this, less than 9.02, 9.02 is right here. Below that, well, let's also think about this. If it's 99.7 from here to here, that only leaves 0.3, so it leaves 0.15 out there. So if I want 902 and below, it's this plus this together. So you have 2.35 plus your 0.15 gives you your 2.5. Okay, I put it as a percent. Actually, it's asking for a probability, so you really probably should put that in there. Okay, next one, between here and here, we're going to add this plus this plus this plus this. Okay, so the 2.35 plus the 13.5 plus the 34 plus the 34. Okay, and that takes you up to the 9.17. So So that gives you 0.8385. So 83.85% of the chips will have this. Okay, so if we're thinking about if it's a 9-ounce bag of chips, this is almost 9, right? What percentage of the bags will have less than 9 ounces in them? So about 2.5% of the bags that are produced will have less than the advertised amount. So they can adjust their what they want to do with their production if they need to. Okay, number 11, Rafael Nadal. First serve, he's a very good tennis player. His speeds in miles per hour in a recent season can be modeled by this normal distribution. We want to find the mean, and these points right here are 1 and 2 and 3 standard deviations away. So what is the standard deviation? Okay, so what is the mean and the standard deviation? Okay, our mean is always the middle number here, right? So 115. He serves a tennis ball 115 miles per hour, pretty fast. Okay, and our standard deviation is how much we're adding every time, right? So how much am I adding between here and here? I'm adding 6, adding 6, adding 6, right? Subtracting 6, subtracting 6, subtracting 6. So a standard deviation of 6. For question number 6, we want to know where is it greater than, how many of his serves are greater than 121 miles per hour? So 121 miles per hour is 1 standard deviation below, right? So if we're thinking about this 1 standard deviation below, greater than that would be these right here. So if I take those and add those together, I get 16%. So 16% of his serves are greater than 121 miles per hour. Imagine a tennis ball coming at you that fast. That'd be fast. Anyway, next one. How many of them are between 109? So that's 1 standard deviation below, and 133. Okay, so which is up to right here. So we got 33, 34, 34, 13.5, and 2.35. Okay, so if you add those together, you get 0.8385. So 83.85% of his serves are greater than 109 miles per hour.